Hello my dear students, in this lecture we are going to see series and parallel connection of spring. Now this is again very important for competitive exams. Now very first we will see springs in series. So make a note that springs in series, right? Now if springs are arranged in series, then what will happen to the springs and what will happen to the properties, right? Now very first, let us say two springs are connected in series. Here I am considering with simple example. Let us say there is a spring 1. Let us say this is the first spring having stiffness k1, right? And there will be another spring having stiffness k2. There are two different springs having different stiffnesses, right? And they are connected in series. Now my dear students, let us say on these springs force P is applied. Now here I will apply force P along the axis. Now because of this force, now can I say this force P is acting on spring 1 as well as spring 2? Right. Here there is a spring 1. Here I will write S1 and spring 2 S2. Right. Means the same force is acting on spring 1 as well as spring 2. And because of this force P, can I say the spring 1 will get deflected by delta 1 amount? And because of this force P, the spring 2 will get deflected by delta 2 amount. The deflection will be different in different springs. And here in first spring, the spring stiffness K1, which is nothing but force divided by deformation 1. And in second spring, the spring stiffness K2 will be equal to force divided by deformation 2. Right. Now, instead of using these two springs, if I want to make equivalent spring, here I am making equivalent spring of these two springs in series. Then there will be an equivalent stiffness of this spring. For this spring, there will be a K equivalent, right? And the force acting on the spring will be the same. The force will be same, and this equivalent spring will deform by delta amount, right? This equivalent spring will deform by delta amount. Now my dear students, definitely this K equivalent will be equal to force divided by deformation, definitely, right? Now can I say in all springs, that is spring 1, spring 2 as well as equivalent spring, the force is same, right? The force is same. Therefore can I say here, as force is same, force is nothing but K delta, right? Force is nothing but K delta, which is same. And here for equivalent spring, the deformation will be here deformation of first spring as well as deformation of second spring. Therefore can I say the deformation will be equal to deformation 1 plus deformation 2? Definitely we can say like this, right? Therefore my dear students, from this equation we can say deformation is equal to P divided by K, force divided by stiffness. Therefore from here for delta it will be K divided by delta is P divided by K equivalent, which is equal to delta 1. Delta 1 is nothing but P divided by K1. P divided by K1 plus delta 2 is P divided by K2. Therefore from both sides P will get cancelled. Therefore 1 upon K equivalent is equal to 1 upon K1 plus 1 upon K2. This is how we can find equivalent spring stiffness. Again, therefore 1 upon K equivalent can be written as cross multiply this K2 plus K1 divided by K1 K2. Therefore K equivalent for two springs in series can be calculated as K1 K2 divided by K1 plus K2. This is a shortcut to find equivalent spring stiffness for two springs in series. But my dear students, it is not necessary that there will be only two springs in series. There may be n springs in series. Let's say n springs in a series are attached. Therefore for such cases 1 upon K equivalent will be equal to 1 upon K1 plus 1 upon K2 plus 1 upon K3 plus so on, whatever may be the number of springs. Now after springs in series, the second combination is springs in parallel. Springs in parallel, right? There will be a parallel connection of two springs or three springs, whatever may be the number of springs. Now here, let us say the two springs, here my assumption is simple case. Let us say I am assuming there are two springs connected in parallel. Let us say this is spring number 1 and there is another spring number 2, right? These are the two springs connected in parallel. First spring will be having stiffness K1, second spring will be having stiffness K2, and these two springs are connected in parallel, means there will be a common load on these two springs. Common load is P, right? And my dear students, parallel connection means the spring will deform by same amount. Both springs will deform by same amount. Means because of this common load P, the both spring will deform by same amount. Let us say the deformation is here delta. Let us say this is the deformation of both springs delta. Therefore, here definitely we can say deformation of first spring is equal to deformation of second spring, right? And this total force P, this total force P will be shared by spring 1 as well as spring 2, right? Therefore, there will be a, for resisting this deformation, there will be a reaction in spring 1, that is force P1, and reaction in spring 2, that is force P2. Therefore, this spring stiffness K1 will be equal to P1 divided by delta, and spring stiffness K2 will be P2 divided by delta, because delta is same. In both cases, delta is same. Now, instead of these springs in series, parallel, instead of these two springs, if I use equivalent spring, let us say if I use equivalent spring, what will be the stiffness of this equivalent spring? Now, on this equivalent spring, force P is applied. Now, deformation is delta only, right? And K equivalent, we have to find K equivalent. K equivalent will be equal to P divided by delta. Therefore, now my dear students, here one thing we know that the deformation delta 1 is equal to delta 2 is equal to delta. Deformation in all springs will be same. But this total force is shared by spring 1 and spring 2. Therefore, total force P will be equal to force in spring 1 plus force in spring 2. Therefore, what will be the force? Force will be nothing but K delta. Therefore, total force will be K equivalent into delta. K equivalent into delta is equal to P1 will be K1 into delta plus P2 will be K2 into delta. Now, from all side, delta will get cancelled. Therefore, K equivalent will be equal to K1 plus K2. This is the equivalent stiffness for springs in parallel. Now, if there are n springs in parallel, n springs in parallel, let us say parallel, then equivalent spring stiffness will be equal to K1 plus K2 plus K3 plus so on for n springs. And for series, n springs, for n springs in a series, we have just seen series 1 upon K equivalent, reciprocal gets added. 1 upon K equivalent is equal to 1 upon K1 plus 1 upon K2 plus 1 upon K3 plus so on. This is how the equivalent stiffness can be calculated for series and parallel combination. Thank you, dear students. In next lecture, we will start numericals on this topic.